Towards a New Socialism. Section: Consumer Goods and the Macro Plan. In the last chapter, we discussed the issues arising in connection with the distribution of social labor between different end uses. In that context, we denoted the total social labor devoted to the production of consumer goods by consumption. Let us now denote the total expenditure of labor tokens on consumer goods by token consumption. The macro plan aims at holding token consumption and consumption as close to equality as possible. This involves jointly A. setting the level of taxation, and B. forecasting the saving behavior of households. The planners do have some means of influencing net household saving, but some element of forecasting is likely to remain, and this means that the exact quality of token consumption and consumption is unlikely to be achieved. If net saving falls below the forecast, then token consumption will exceed the predetermined level of consumption. In that case, the planners may respond in the next period by raising taxation, encouraging more net saving in one way or another, or increasing the allocation of social labor to consumer goods. Or, if the planners reckon that the sub-forecast saving was a temporary blip, they may choose not to respond. Exactly parallel reasoning applies in the case where saving is above the forecast level. This means that although equality of token consumption and consumption is a target, which should be realized on average over time, the precise ratio of token consumption to consumption is liable to fluctuate somewhat around 1.0 from period to period. Note that this ratio can be thought of as an aggregate price level of sorts. It represents the average number of labor tokens required to purchase the product of an hour's social labor in the market for consumer goods. Now, the marketing algorithm has been discussed above, uses as an indicator for the reallocation of resources the ratio of market clearing price to labor value for each consumer good. In the first presentation of the idea, we assume that the average of this ratio across all consumer industries should be 1.0. We can now see that this is a slight oversimplification. If we form a weighted average price-to-labor content ratio across all goods during one period, weighting each commodity by the proportion of the total consumption which the commodity accounts for, this average will identically equal the macroeconomic ratio of token consumption to consumption, which, as we have just seen, may diverge from 1.0 to some extent. In the light of this macro consideration, we can reformulate the consumer goods marketing algorithm more precisely as follows. 1. The Central Marketing Authority, CMA, places orders with the producers of consumer goods of various types, subject to the constraint that the orders have a total labor content equal to the planned overall consumption allowance for the current period. 2. The CMA receives the output it ordered and sells it to consumers at market clearing prices. 3. The ratio of market clearing price to labor content is calculated for each product, and the total expenditure of labor tokens, token consumption, is recorded. Then, for each product, the following decision rule is applied. If price divided by value is greater than token consumption divided by consumption, then increase orders for that good. Or, if price divided by value equals token consumption divided by consumption, then maintain orders for that good. Or 3, if price divided by value is less than token consumption divided by consumption, then reduce orders for that good. Increased resources will therefore be devoted to lines of production where the price divided by value ratio is above average, while resources will be withdrawn from the production of goods having a below average price to value ratio. And then finally, step 4, go back to step number 1. Some of the steps in this algorithm stand in need of elaboration. Step 2 requires that the marketing authority sets market clearing prices for all consumer goods. This is easier said than done. It is easy enough to specify a rule for moving towards the market clearing price. Raise the price if there is an excess demand for the commodity, lower the price in the case of an excess supply. But how big a change should be made? Absent the economist's theoretical fiction of the Walrasian auctioneer, it is not possible directly to determine the set of prices which will clear all consumer goods markets. Strictly, we should say that prices are set at approximately market clearing levels. The planners must work by trial and error, informed by the results of statistical analysis of demand elasticities, much as capitalist firms with market power, and hence able to set the price for their own output, do at present. Further, it is not clear that movement to, quote, perfect market clearing prices, which exactly balance the flow demand with current production, would be desirable even if it were possible. This might give rise to excessive price fluctuations. For any storable commodity, changes in inventories provide a means of damping market price fluctuations. Excess demand can be met in part by a rundown of inventory, rather than putting all of the adjustment onto the price. Some more detail on step 3 of the algorithm may also be useful. This step calls on the planners to increase or reduce production on the different consumer goods, depending on whether they show a price-to-value ratio higher or lower than the social average. The objective here is to produce just enough of each commodity so that its market clearing price equals its labor value, a ratio of 1.0. Just as with finding market clearing prices for each period, this must be an informed trial and error exercise. Finding the output level, which will make the market price assume some specific level, is the inverse of the problem of finding the price which will clear the market given some predetermined level of supply. The problem can be solved directly only if one knows the demand equations for all goods in exact detail, including the spillover effects, whereby change in the price of any one commodity affects the demand for others. A second complication is that the labor value itself may be a moving target. Altering the scale of output of a given product may alter its labor content per unit. If economies of scale predominate, the labor value of a commodity will tend to fall as the output of that commodity is increased. If diminishing returns predominate, labor values will increase with the increased output. For these reasons, we should think of the consumer goods marketing algorithm as always moving towards the price equals value condition, rather than achieving a static state with prices equal to values throughout. In this context, one special feature of the algorithm deserves attention. The fact that each good is marked with both a labor value and a market price may induce some degree of stabilizing speculation, limiting the fluctuations of market prices. The point is that the current labor value of a commodity gives some guide to its probable long-run price. Suppose that a particular good is currently trading at a price substantially above its labor value. Seeing this, consumers may decide to postpone consumption of the item in the anticipation of a lower price in the future. Conversely, if a product is selling for much less than its labor value, that will suggest to customers that it is a temporary bargain, which may increase the current demand. Such speculative shifts in demand will tend to limit the divergence of market prices from values by damping the demand for items with above value prices and stimulating the demand for items with below value prices. End of section.